Hi, I'm Dave Dooling, Education Director at the New Mexico Museum of Space History. Welcome to another episode from the Space Vault, a look at artifacts that we have in storage. Today, we'll talk about the story behind this odd soccer ball-looking satellite stashed high on a shelf. This is a full-scale model of the Vela Hotel satellites, first of a series of space sentries that the United States launched starting in 1963. Vela, Spanish for watchman, was a network that watched for nuclear bomb tests. And that means we have to roll back to the end of World War II when the United States tested the Trinity gadget and then dropped the first atomic bombs on Japan. The United States was the world's only nuclear power until August 29, 1949, when the Soviet Union detonated Joe 1. In 1952, the United States detonated the first H-bomb, and the Soviets were close behind. Test sites around the world shook with hundreds of nuclear blasts in the air, underground, ocean, and even in space. Both nations talked about stopping tests and slowing the new arms race. Following the Cuban Missile Crisis in October 1962, the U.S. and USSR hammered out a limited test ban treaty. U.S. President Kennedy insisted that Congress provide for verification before he would sign the treaty into law. Congress did, and 10 days after Kennedy signed the treaty, the first Vela Hotel satellites rocketed into space. It seemed like America had pulled a rabbit out of the hat. But the real trick is hiding the rabbit in the hat in the first place. As well as developing the first nuclear weapons, Los Alamos National Laboratory had been working hard on methods to measure blasts. These grew into technologies for detecting whether the Soviets or others had tested bombs. In 1947, the U.S. Air Force was directed to develop a capability to detect nuclear tests anywhere in the world. In 1949, an Air Force WB-29 reconnaissance plane flying out of Japan picked up fallout from the Joe test, which the Soviets had not yet announced. The Soviets surprised the United States again with an H-bomb test in 1953, less than a year after America's first test, and then with the launch of the first artificial satellite, Sputnik 1, on October 4, 1957. These surprises spurred three major changes in the United States: the National Defense Education Act, the formation of the National Aeronautics and Space Administration, and the formation of what is now the Defense Advanced Research Projects Agency. DARPA immediately established the Vela or Watchman project with three parts. Vela Uniform and Vela Sierra would detect underground and surface tests. Vela Hotel would watch for tests in space. On June 10, 1959, Los Alamos and Sandia National Laboratories in New Mexico started work on Vela Hotel. But how to do it? Scientists had known from the very first tests that nuclear bombs release energy across the entire spectrum, from infrared or heat radiation through light and up to X-rays and gamma rays. Their fallout will glow in X-rays or gamma rays for days after a test. You cannot see this radiation directly, but you can see its results. X-rays and gamma rays will energize electrons and materials, which is easily detected. Easily is misleading. Space is hardly the vacuum of sci-fi movies. Energetic bits of atoms, as well as natural X-rays and gamma rays, zip about and can trigger false readings. So, Sandia had to cram the power of a room-sized computer into a small package weighing a few hundred pounds. That much power was needed to process and record data from radiation detectors aboard the satellite. TRW designed and built the satellites. A small solid rocket motor sat in the center, electronics sat on a platform at the middle, and solar panels covered the outside while detectors stared out from the corners. Ironically, it slightly resembles Fat Man's explosive lens assembly. Initially, they weighed 300 pounds each and were launched on Atlas Agena rockets. The success of the first three pairs led to a contract for 3 pairs of advanced Vela Hotel satellites. The design expanded from 12 to 24 panels and doubled in weight to almost 600 pounds. This required the more powerful Titan 3C as a launcher. 2 satellites at a time were launched, the first on October 17, 1963. And not in secret, it was important that the Soviets and others knew that we were watching. The Velas were placed in orbits around 70,000 miles high. 2 satellites at opposite sides could watch the entire globe. The satellites were built so well that in time 4 were always in orbit. Backup hardware was assembled into the last of 6 pairs launched April 8, 1970. As it is for most watchmen, the job was largely boring, but it was worth it. By the time they retired, the 12 Vela Hotel satellites had detected 41 nuclear flashes and yielded other surprises. On July 7, 1967, the 5A and 5B satellites detected a flash of gamma radiation, while the other instruments remained silent. The data were not noticed for a few months until Los Alamos scientists had time to follow up on a suggestion by Sterling Colgate. He advocated for gamma ray detectors on Sentry satellites since the nuclear tests in space might be shielded, but decay products would emit gamma rays for several days. Oh, and by the way, the shock waves from exploding stars might also emit gamma ray flashes, so we need to study them so we know what to ignore. In going through the data, scientists found a single peak event unlike a nuclear flash. None of the other detectors recorded anything, and the arrival times at the two satellites pointed to outside our solar system. Over the next 5 years, data from the Vela 5 and 6 pairs helped Los Alamos scientists discover 16 gamma ray bursts. Their findings, published in June 1973, helped kick off the dynamic field of gamma ray astronomy. With ground and space-based instruments, Los Alamos became a world leader in this new field that includes thousands of sources. Vela Hotel made other scientific discoveries, including the plasma sheet, a layer of electrified gas along Earth's magnetic equator, heavy ions in the solar wind, and X-ray bursts, where hydrogen fuel accumulates on the surface of a neutron star and explodes like a runaway H-bomb. And secret bomb tests? Maybe. Its 41 test alarms were all accurate, with one maybe, the infamous 747 incident on September 22, 1979. Vela 5B, first to carry extremely fast light sensors to observe the first microseconds of a bomb test, detected a bright flash over the ocean between South Africa and Antarctica. Was this the perfect place for a secret bomb test? Perhaps. The Velas showed the distinctive double peak caused by the superheated air around a blast absorbing energy for just a millionth of a second. Other instruments on the Velas detected nothing, but ground instruments said something happened. The story is mired in controversy. Some experts believe that Israel and South Africa tested the trigger for a neutron bomb at Earth's most remote stretch of ocean. Others contend it was a terrestrial lightning flash or even a micrometeoroid striking the satellite. Whatever the cause, the uncertainty led to a new generation of spaceborne sensors aboard Defense Support Program satellites that watched for missile launches, and the Global Positioning System satellites that revolutionized modern navigation. The last Vela Hotel satellites were turned off in 1985, but Los Alamos and Sandia continue to work on next-generation global burst detectors for the National Nuclear Security Administration. And they have put their expertise to work on a range of spacecraft, including advanced observatories to study gamma-ray bursts. Thanks for watching, and stay tuned for another look inside the Space Vault.